The Nile. For millennia, it has been a source of life, culture, and commerce for Northeast Africa. Without the Nile, there would be no Egypt. And without the water from the Nile, there would be no pyramids. Stone by stone, the Egyptian pyramids were constructed by harnessing the power of water rather than ropes, ramps, and the strength of men. The Egyptian pyramids were built at a higher elevation, on an open plain, to be visible without obstruction to Re, the god of the sun. Scholars say that beside each pyramid was a mortuary temple connected to a causeway. At the other end of the causeway was a valley temple. Many envision an arid landscape surrounding the pyramids, as it is today. This theory hypothesizes that it was just the opposite. Let's think about the pyramids differently for a moment. This theory presumes that there was a lake or water basin with a harbor beside every pyramid built in ancient Egypt, and that each pyramid was connected to this harbor by a causeway. The causeway ran from the pyramid down to a temple, frequently called the Valley Temple, located at the nearby lake or water basin's edge. This theory suggests changing the name Valley Temple to the more appropriate Harbor Temple, due to its proximity to the water's edge. Saqqara, an expansive Egyptian burial ground where some of the 5th and 6th dynasty pharaohs built their pyramids, is home to Unis's Causeway, one of the best preserved examples of the causeway. There are locations in this area with multiple pyramids that are built near one another with causeways leading towards a body of water. The causeways led to the lake, and this lake was connected to the Nile River by man-made canals. Ancient texts confirm that pharaohs called upon the Egyptian people to build such canals. 4,400 years later, this lake has dried up. However, evidence remains that lakes were present during this time. When Pharaoh Khufu sent his builders to survey the future site for his pyramid, they found that the Giza Plateau offered everything needed for a colossal pyramid site. The Giza Plateau was near the Nile River and a probable small lake. The area was made of limestone layers and offered a solid foundation to support the massive pyramid. The limestone also supplied core stones for the pyramid. Fast forward to the 1980s, an American-British consortium, Ambrick, drilled 72 boreholes before installing a new sewage system east of the Giza Plateau. These boreholes yielded information about the terrain, precisely sediment deposit depth below the surface and elevation to sea level. This data and research from books, maps, photographs, and other materials was used to develop this revolutionary theory of how the Egyptians used waterways to move building material within the Khufu Basin. Most scholars agree that over time, the Nile River has migrated eastward. The former Nile Channel, or Western Branch River, is now referred to as the Labini Canal. The Labini Canal is next to the Giza Plateau. Archaeologist Dr. Mark Leonard showed that there is silt and clay 2 to 5 meters above sea level in the Labini Canal, confirming the old Nile River's location and depth. The Nile River was the only possible source for this silt and clay. At the foot of the Giza Plateau, there was likely a small permanent lake. The boreholes showed sand, silt, and clay bordering the Wall of Crow on the south and Khafre Harbor Temple on the west. The deepest, lowest point of the basin was the same depth as the lowest level of the ancient Nile River, or branch channel, as it is in front of present-day Khafre Harbor Temple. The probable small lake Khufu's builders found when scouting the pyramid location would have been in this area. During the spring and early summer, the Nile Channel water level was approximately 3 meters deep, which was 5 meters below the floodplain. The water table in the Khufu Basin would have also been lower, 0 to 3 meters deep. At this time of year, water would only be present in the probable small lake. There would be enough water to operate canals to the pyramid base and sluices on the pyramid all year. Still, without a method of controlling the water flow, water transportation would have to stop within the basin for a few months due to low levels.